Okay, it's time to start our last unit in the course, which is called electrochemistry. Now, this unit is pure chemistry. So the magnetism, electromagnetism, mirrors, and lenses were pure physics. Atomic, quantum, and nuclear you will find in both chemistry and physics. This one, pure chemistry. Okay? And so today was just going to be a bit of an introduction to what electrochemistry is. And so to begin to understand it, we have to talk about a word that you may have heard of before, but probably don't use very often in your life. It's called metallurgy. Okay, obviously it has something to do with metals. Metallurgy. I think I first encountered it when I was in school and we were reading a book about Paul Revere and the Boston Tea Party. And anyway, if I remember correctly, I think it was Paul Revere that was a metallurgist. Just thought I'd tell you that. I could Google it, but what fun would that be if I actually fact checked? Anyway, metallurgy is simply the process of extracting a metal from its ore. So I'm sure you've all heard of like iron ore and that they would mine for iron ore. So when you mine for a mineral, for a metal, most often what you get is that metal mixed in with a whole bunch of other substances. There's actually only two metals that occur pure in the earth that we would find pure, and those two are gold and silver. Okay, but all the rest of them are mixed in with other substances. So when we mine them, then we get this mix, and then if we want the metal, we have to go through a process to get the metal out, and that process is called metallurgy. So it's the process of extracting a metal from their naturally occurring compounds. Okay? And so, like I said a minute ago, there's only two metals, or at least two that we know of. Gotta leave hope for the future. But there's only two metals that we know of right now that occur naturally as pure, and those are silver and gold. It's probably one of the reasons why they're so expensive, right? They're fairly rare too. Okay, the rest then we extract them as ore, so the naturally occurring compound is called ore. And for me at least, and maybe that's because I grew up in Nova Scotia, the most common ore is iron ore. The one that I've heard of most, the most common to me, is iron ore. But I'm sure there are others that are just as common, but maybe in this part of the world, iron ore is the most common. Okay, so the other thing we know about this metallurgy is that it's been done for thousands of years on some metals. Metals like copper, iron, and bronze. And of course, bronze is a mixture of copper and tin. So these metals we know have been extracted from their ore for thousands of years, and we know it because we found the presence of these metals in their pure substance in different archaeological sites. So we know that way back when people were able to separate these. But there are others that are much more recent. It's much more recent that we figured out how to separate aluminum out to be a pure substance, and zinc. Those ones, there were no sign of them thousands of years ago. They're much more recent. Okay, so this process of refining a metal out of its ore varies from metal to metal. Some can be really simple, others are a lot more complicated. Obviously, the much more complicated here would be aluminum and zinc, and that's why it took that those two weren't, we haven't found any evidence that those two were done years ago. But the process of separating copper and iron would be easier or more simple, and that would be why they'd be able to have been done longer ago. Okay? But all of the processes, no matter what they are, what they look like, they all involve a large quantity of ore being reduced to a smaller quantity of the pure metal. Okay, so they all involve a large quantity of ore being reduced to a smaller quantity of pure metal. And because of that, this process is often called reduction. Reduction. So reduction is a reaction which produces a metal from its naturally occurring compound. Okay, it's a reaction which produces a metal from its naturally occurring compound. Now, if you're using the notes that I posted on our site, you will notice under the definition for reduction, I have a couple of spaces. And I'm going to come back to those as we go on here to fill in a bit more about reduction. But that, if I told you now, it would be like spoiler alert. So for right now, we are going to say that reduction is simply a reaction which produces a metal from its naturally occurring compound. And that is true. It's also more than that. But we're not ready for the more than that yet. We have to do baby steps first. Okay, so if we look at some examples then of reduction, iron ore is Fe2O3. And if we bubble carbon monoxide gas through it, the iron will separate out into Fe solid, and there'll have to be two of them, and the other product will be carbon dioxide. Okay, so this is an example of a naturally occurring compound like iron ore being reduced to its pure metal, pure iron state. Okay, a second example would be SnO2, so tin oxide, and when it's in the presence of carbon, the tin will separate out. Whoops, that doesn't need a bracket there, sorry. Sn solid, and again, a byproduct would be carbon dioxide. Okay, and so again, it's taking the ore, the tin oxide, and it's reducing it to just pure tin. Okay, so to its pure metal. A third example, copper sulfate. CuS, in the presence of hydrogen gas, will turn into pure copper and hydrogen sulfide, which is a gas. Okay, so again, the metal ore being reduced to the pure metal. Now, the entity, the other substance in each of these that's causing this reaction to happen, really, this guy is causing the reduction to take place, and so because of that, we call it the reducing agent, right? Because the iron ore, the tin oxide, and the copper sulfate would not turn into pure iron, pure tin, and pure copper without this reducing agent. Okay? And so it's a reducing agent because it causes or promotes the reduction of an ore or a metal compound into its pure metal. Okay? So this is reduction. And like I said a few minutes ago, we'll come back as we go on and add a couple of other little notes to that. The second type of reaction that we need to look at is when you take a metal and you turn it into a compound. Okay, so thousands of years ago, just like thousands of years ago, they figured out how to pull out copper. Thousands of years ago, they discovered fire. And later realized the role of oxygen in the burning. And then later we realized that things like corrosion, rust, it's really just a slow fire happening, a slow oxidation happening. And then like gunpowder would